All right, worked example 8.2a I've started on. This is because I mucked up the last video and I've already done this. All right, so we're going to start with a magnetic field strength of 4 milliteslas. And as we read on, the field strength is suddenly reduced. So I'm going to need, this is my initial field strength. This is my final field strength. This passes through threads. Remember, means it just goes through. Just like threading a needle, the thread goes through the eye of the needle. So threads through a loop of area 1.5 meters squared, so that's area, at right angles to the plane of the loop. The magnetic field is suddenly reduced to 1.0 milliteslas in 0.5 seconds. So that's going to give us our rate of change. That's the time that it happens in. That's our final. That's our initial. We've got the area. We can work on an angle. We've got delta t. So let's draw up what it would look like. So this is example 8.2a. Righto, so we've got our loop here. It'll look something like this. And it starts off with 4 milliteslas. This is BI. The area was 1.5 meters squared. And the angle here, we measure the angle. The angle gets measured from the magnetic field lines. So in this case, because this was a right angle and it's going straight up our angle theta equals 0. I think that might be the hardest thing to work out, what the angle is. Righto, so that's going to change in 0.5 of a second, that's our time, to this situation where we just have 1 millitesla. The area is unchanged. All right, the rule for, what have we got? We've got B, we've got A, theta equals 0. B is in two forms. BI equals 4 milliteslas. BF equals 1 millitesla. Righto, so our rule for flux is BA cos theta. Part A of the question wants to know the change in flux. So the change in flux is going to be BF minus BI, A cos theta. So we would have 4 by 10 to the negative 3 minus 1 by 10 to the negative 3 times 1.5 cos 0. Oh, I accidentally put a stroke through it. That's all good. So that works out to be delta phi Oh, did you pick up my mistake? I've put these in the wrong order. That should be 1. That should be 4. Well done if you spotted it. So that gives me a negative answer. And the answer is 4.5 by 10 to the negative 3. And if you remember, that's measured in Webers. Cos of 0 is 1. So that's one. So that gives me the change in flux. Then it says, what EMF will that produce? So an EMF is produced. We need a change in flux divided by a change in time, and we need to know the coils. Well, in this case, there's just one coil. So we've got negative 1 times negative 4.5 by 10 to the negative 3 divided by 0.5. So we get 9.0 by 10 to the negative 3 volts, which is 9.0 by, millivolts. There we go. Oh, better move my camera down, sorry. So this was a 1 because it was just one single loop of wire. So that's why that's a 1. That was the change in flux that we calculated up here. That was the change in time, and that gives us the EMF produced.